First of all, I want to thank Sean Thomas for a great presentation. As a co-presenter, couldn't have been a better presentation ahead of mine. I think it's exciting innovation that he's working on, and I congratulate him on a great presentation, but also on a lot of hard work. I can imagine what went into it, Sean. So thank you very much. I also want to thank Christian Wurzer and the UK Biochar Center for hosting us and bringing us back a second time to address this great session on green carbon. Ours is called Crossing the Chasm, the Adoption of Biochar. And why don't we dig right into it, Mark? So what we see in front of us is what is typically called a normal adoption curve. And below, you'll see categories of adoption that are typical in any innovation that comes to market. I'm sure that everyone on this call, I think there's about there's over 50 people on this call, maybe 60, that all have mobile phones, and mobile phones are considered an important human invention, as it has been one of the most widely used and sold pieces of consumer technology. And since everybody watching this webinar has a smartphone of one type or another, it wouldn't be surprising that everybody is in now early and late majority on this curve. But some of you might have been either innovators or early adopters with cell phone technology. The first handheld mobile phone was demonstrated by a fellow by the name of Martin Cooper out of Motorola in April of 1973. And you might be surprised to learn that the first cellular network was launched in Japan in 1979. And it wasn't until 1983 that most people began adopting the cell phone. And of course, in 2007, the iPhone came out and showed that it was more than just a phone, that it was a multitask tool. And so the question is, well, not the question, but it allowed cellular technology to cross what we call a chasm, which is the next slide. And that chasm is the area where many technologies are adopted or fall and are never seen again. So getting a new idea adopted, even when it has obvious advantage, like the cell phone, it took a while, and it's often very difficult. Many innovations require a lengthy period, and biochar is no different. Everybody likes to cite biochar being discovered by the conquistadors when they went to South America and saw the Amazon and discovered what we call today as biochar as terra preta, black earth. And then again, soil amendments became very big, and that is a big focus of biochar today. And we even saw it in the previous presentation by Sean Thomas about dropping seeds into forestry areas. So it's a lengthy period, as I said, to get adoption to occur. And from time to time, they become available when they're widely adopted. But it goes back as far back as 1513, when Machiavelli in The Prince wrote about the adoption of innovation. And he wrote, "There is nothing more difficult to plan, more doubtful of success, nor more dangerous to manage than the creation of a new order of things. Whenever the enemies have the ability to attack the innovator, they do so with a passion of partisans, while others defend them sluggishly, so that the innovator and his party alike, all of us here together that like biochar, are vulnerable." And so we have been vulnerable all over these years. Diffusion is how new technologies and advancements spread throughout societies and cultures. And biochar is no different. And it describes a pattern and a speed in which these new ideas and practices or products spread throughout a population. The main categories, as you can see, are innovators. And the innovators are the people that typically have a lot of money and have a lot of time on their hands and want to bring something innovative into the marketplace. And as you can see, typically they're the smaller portion of the population. And the people that follow them and that look to the innovators are what we call the early adopters. And the early adopters are people like us on this call that are in the biochar arena. most of the people I imagine that are watching this have some knowledge of biochar, and we don't have to go into the description of what biochar is. And people like Sean is an early adopter and innovator in that category, and along with all the folks in Finland and around the world that are trying to get adoption of biochar into the marketplace. And of course, as Sean pointed out in his presentation, there's a lot of research that is done, and some of the research is effective and some of it is ineffective. And that's where the chasm lies. And the early majority of people are the vast majority of the people on the marketplace, like everybody here that also is early majority and late majority of have cell phones. We're not quite there yet with the adoption of biochar. And of course, laggards are the last people on the earth that will adopt anything. And you can imagine, going back to the cell phone analogy, if there are people out there that don't have cell phones, and there are people that, if they got cell phones, they still have their old flip phone. They don't even have a smartphone. So that's the problem with the chasm, and those are the categories of who the innovators, the early adopters, and the early majority, late majority laggards are. The next slide, please. So in order to be successful for biochar, what we need to do is we need a bridge across the chasm. And in today's presentation, I'm going to demonstrate the advanced resilient biocarbons bridge across the chasm. Now, there can be more than one bridge, just like there's more than one bridge across the Hudson River. We can build many bridges across the chasm for biochar. And today I'll be talking about how we've built our bridge across the chasm into early majority. Let's go to the next slide. So in order to understand what the bridge is, you first have to address the challenges of adoption. And the basic three fundamental challenges so far have been, in modern times, at least since 2010, insufficient and problematic supply. In other words, there's not enough biochar for demand. And the types of business structures out there have been very difficult to get in place. As I think Sean talked about in his presentation, there were early on people that had money in it, and then the government came back and prevented them from doing the types of innovation that he's trying to bring into the marketplace. And so again, that's a chasm that has to be crossed. And of course, the other issue and that we run into are what we call the biocharlatans, pun intended, folks. Those people who are what are called greenwashing. They tell you that biochar works, but they're not giving you biochar, or they're giving you some other solution that is really not viable. So those are the challenges. Next slide. So actually, what I'm showing here is in more detail the 5 stages of diffusion of innovation. And these, I didn't make this up. This came from a fellow by the name of Everett M. Rogers, and he wrote the book on diffusion of innovation. And he describes the 5 stages or steps, which are awareness, interest, evaluation, trial, and adoption. And these are all important to the adoption or the lack of adoption of an innovation. And that goes specifically for biochar. And if you see that you can see it even delineates the typical percentage of people who are adopting over time. And if you see the orange curve, that orange curve is the cumulative number of adopters over time. And that's what he mathematically equates. And for each type of innovation, including each type of biochar out there, you can create an adoption curve. So it's very important to understand this so that we can help create that bridge across the chasm. Next slide. So understanding biochar adoption and why it's difficult. I'm sure, I think we even have one of the authors, Albert Bates and Kathleen Draper, wrote a book called Using Fire to Cool the Earth. It's called Burn, Using Fire to Cool the Earth. And in that book, they talk over 100,000 uses of biochar. Well, which one do you use? How do you focus on it? The good news is that Sean is focused on the seed approach for forestry. So that's one way of getting across the chasm by focusing on a market. Also, in many cases, as we saw with Sean's applications, they are prescriptive. What do I mean by prescriptive? Think of medicine, think of pharmaceuticals, think of somebody inventing invented penicillin and somebody else invented erythromycin. They're not all appropriate for solving a person's health issues, but they have to be tested and found out. So they're prescriptive in nature. And of course, the quality must be verified. If you can't verify the quality, everybody thinks you're going to be a biocharlatan. And of course, we know that the supply must satisfy the demand, and there's huge demand out there. In order for that to happen, we need technology that's industrial in scale and production. Next slide. So some of the high demand and low supply examples of uses of biochar and outcomes are that it sequesters carbon, it filters water, it removes toxins and heavy metals, it enhances and restores soil, as was presented in the first presentation, and it reduces agricultural water usage also, and refines and can be refined into graphene for electronic devices, and it can even be converted into activated carbon. That's done typically, people know activated carbon from coal, but we also use activated carbon from coconuts. Next slide. In order to move forward and create the bridge that we've created across the chasm, we had to understand that there are two fundamental economic models, an inelastic and an elastic market. So what are those markets? An inelastic market is when the price of goods or services go up or down and consumers' buying habits remain unchanged. Classic example is gold. I don't know if you know this, but gold reached a little over $2,000 a troy ounce. And it doesn't matter whether you buy 1 troy ounce or 10,000 troy ounces, that's the price. The price doesn't vary. In an elastic market, that's when prices are low and supplies are tight and demand increases and prices rise. And then when prices and availability affect buying habits significantly. Commodities are highly elastic. Prices change along with the supply and demand. The classic example is pork bellies. Maybe you've heard that on a Bloomberg broadcast, or you listen to financial news. Pork bellies are always going up and down, and they are affected by price changes along with supply and demand. Next slide. So the other element in getting across the chasm is understanding, and we saw that specifically with the questions that were asked about Sean's presentation. Biochar production is customized. It's customized by feedstock input, by temperature that you run it at, and the duration or residence time. And we know that because of all the hundreds of thousands or the 100,000 uses of biochar, production is far below demand. There's a lot of demand out there, but we just don't have the capability currently to deliver, although that has changed now. Next slide. And so what we're seeing here is that, and I'm sure a lot of you folks have been following the COP28 conference and our representatives of IBI at Biochar, representing Biochar, and the EU representing Biochar at the COP28 conference, and trying to get the message out that biochar is addresses a carbon cleansing economy. It sequesters, it repurposes, it restores, it filters. Literally, it reclaims the environment, and it's probably one of the top carbon cleansing tools that we can bring to the marketplace. Next slide. So what is the solution that we're bringing to the table? We have 7 entry wedge markets that we're addressing, and we're able to do that by addressing 3 inelastic markets: the graphene-like material, the animal husbandry feed supplement, and the circular mining extraction market. In my last presentation on this webinar series, on the 8th annual webinar series, I spoke specifically about circular mining and mineral extraction markets and how we've done that in Europe and around the world, and we're doing that now. And The graphene-like material is very important. Just so you know, graphene goes for 4 cents an ounce. So if you're able to supply that market, you can make a lot of money. An animal husbandry feed supplement. This is not necessarily soil amendment. This is where you put it in the feed of animal husbandry, of livestock. And we know from the cost action on biochar, we've discovered that it reduces the mortality rate of livestock. And that's not just cows. Mostly in America, we think about cows reducing methane, but it reduces the mortality rate of cattle, goats, pigs, sheep, whatever goes into the food channel by a minimum of 50%. That's a minimum. And that's a statistic that you can take to the bank. And that's really important. And it's prescriptive in nature because even though in the United States, it's not yet legal, but it will become legal. And we're closer to doing that in Canada. It'll be brought to the market and like a drug, and it'll be addressed by veterinarians prescribing it to different types of livestock. And on the elastic side, we have charcrete for building and construction materials, soil amendments, we've talked about that, electricity and power and thermal energy, water for purification and filtration. And these inelastic markets on the left are what allow us to bring the elastic markets across the chasm and get greater adoption. Next slide. So we bridge the chasm profitably. We've targeted these 7 entry wedge markets. We provide prescriptive biochar for each target market. Our output quality is verified by the Climate Bond Initiative Waste Management Taxonomy. That is a science-based taxonomy or set of rules. And we have technology that supplies and satisfies high demand. We can also mass produce our technology in large quantities, and we are able to do it in Europe, which allows us to get our climate bonds. And the technology provides that industrial scale of production that is required now. Now, that's not to say that we don't continue to use cookstoves in Africa, but there are various uses of our technology to cross that chasm and create adoption, especially in urban and large areas like forestry areas. So our JVs are funded by the EU climate bonds, and that's how we're able to afford a massive infrastructure lift. Folks, this is an infrastructure lift, and this is where we're heading. This is where biochar needs to head. And if it's not us, it'll be others, and others are doing it, by the way, and we welcome them. We want everybody to do it. Let's go to the last slide, Mark. All right. Yes, because adopting innovations is all about climate restoration and climate repair. That's the mission. Biochar is a tool. Think of it as if you had to have open heart surgery or triple bypass surgery, you're not going to be relying on one surgeon. You have a set of people out there, anesthesiologists, maybe several surgeons, several operating nurses, and then after you get out, you got to go into recovery. This is the approach that we use. We use a team approach, and we welcome everybody to join us in this approach. And if you want to know more, certainly reach out to us. My email is there. My cell phone is there for WhatsApp signal, and I'm more than happy to answer any questions at this time. Thank you.
Thank you very much, Marshall. So the floor is open to questions. If you have, write them into the chat. So for my side, the first question that comes to my mind is obviously, which of the inelastic markets is the one that is working best right now?
Well, that's a great question that you asked, Christian, but that's not how we approach it. It's not what is best, because what that question infers is that you want to focus on a specific market, but it's a multiplier effect. It's a mathematical multiplier effect for adoption to occur. And that's why adoption has been heavily difficult for biochar for millennia, actually, since the conquistadors discovered it in the Amazon. But in modern times, that question is answered by each market having its own viable capability. What we discovered, and the answer to your question is that each market has its own return on investment and its own viability economically, but they're all profitable. And the question is, if you blend them and you do them together, you have a portfolio approach so that if one market drops a little bit, especially the elastic markets, you're supported by the inelastic markets, and one brings the other across. It's not a subsidy, but it's kind of a bridge of getting adoption to occur at greater volumes and into a greater market space, so that Christian, you and I and the rest of the people on this, we will be considered old fogies when it really gets in going in the big time in the marketplace.
So I was especially asking because you have this. I agree with this Chasm, and one big topic on adoption of biochar, at least in Europe, is that we have a lot of regulatory issues. We've actually, even if you're profitable, even if you have a good product, you're sometimes the regulatory framework can be an obstacle. And my question was more targeting it. Do you see some areas where we see more advancement than in others? I mean, I know animal husbandry is already applied in Europe in several places, but for graphene-like materials, I'm not sure. Do we already see something there, or is it
Yes.
still
Yes, the
evolving?
answer is yes, definitive. That's why we've picked it as one of our 7 entry wedge markets. An entry wedge market in marketing terms means that it's your foot in the door, and it generally is easier to get in that door than markets that might be obstructed by regulatory process. So we know that graphene is a big industry. It doesn't have regulatory issues like other areas. And graphene, like char, has been created and used and deployed. And again, the issue is, can you manufacture a quantity of it, because it's the desire is in large quantities. And people are looking at it. It's 4 cents an ounce, whether the same, it's like gold. And the more you buy, the more you sell, and the more you manufacture, the better it is, and it helps those inelastic markets to get adopted.
And I think there was an interesting question from Mandy Hanabi. Would you say that the CDRs, the carbon dioxide removal, I guess, credits, is the main tool to bridge the chasm at this point?
That's a great question. To be perfectly frank with you, our opinion on our group is that carbon credits and carbon set asides need to be regulated. My analogy of that is what happened in 1929. You and I, Christian, could have in 1929, had we been alive, gone to the stock market, the New York Stock Exchange, and opened up a company, and we could have cheated a lot of people, which happened, and it caused a market crash. And it was only after the crash that the United States government created a regulatory process of bringing government companies to the public, and that's through the Securities and Exchange Commission. So we're big believers that biochar is a great tool. It can be a great carbon set aside or a carbon credit, but it needs to be regulated, because we already know that there are tremendous issues with carbon credits, and we are trying to make that go away through a regulatory process. I'm working with the EU on that. I'm also working in the United States on that with the current administration. The carbon credits, you can get them. They are viable. That's how people are making money, but we don't need carbon credits for ours. Our average or low, and I'm using as a reference as a return on investment. Our return on investment is very high. Our gross profits are minimally, not maximally, minimally a 40% gross profit or greater. And it also has to do with the business structure that we've created. The reason we're being funded through the EU climate bond is because we turn brownfields into green fields. That's a regulatory process, Christian. We're following that regulatory process. And by following that, we are able to acquire huge amounts of money for our joint ventures to bring our products to the marketplace. And we also have guaranteed off takers. In my last presentation back in May, I talked about circular mining, and we have guaranteed off takers, 5-year, 10-year off takers. That makes it really easy to generate capital, generate profitability, and get a great return on investment and spread that money into other markets.
Yeah, so you're definitely targeting the product rather than the side benefit of CDR or benefit of
Right.
CDR.
The CDRs are a good tool, but it's our recommendation that people focus on making profit from the product, from the chars, from the biochars, and from their uses. And that's why adoption will occur. In 2019, it got started because Puro.Earth got bought by NASDAQ. And so it took off like crazy. But we've seen a lot of problems and a lot of issues, and now there's a lot of backlash in that area. I'm not suggesting that it's not a good idea. I just think it needs regulation, like companies that want to come to be public companies or to get a bond on the Luxembourg Green Exchange, as we're doing. We need to follow regulations, my friend, and we believe everybody should.
Yeah, I mean, that is in the ongoing, I think in the EU at least, from what I know. So Tom Else was asking, getting biochar for feed legalized is a heavy lift. Do you have a strategy for that?
Yes, we do. And the strategy is we're following EU climate bond regulatory processes. And under the climate bond taxonomies, which are the only taxonomies that are science-based. There are other taxonomies for EU and also here in the United States, and they're mostly political. And if you're doing starting a new company and going public, or you're doing it as we're doing by using a debt structure, that's what a climate bond is. It's debt. You are highly regulated, and you have to show a return on investment. And we've shown that capability for the people who will buy our climate bonds. But in order to do that, we've adopted the most stringent case, which is the Climate Bond Initiative under the Waste Management Taxonomy, which is science-based and is trackable and needs to be verified on an ongoing basis. Without verification, again, people think you're greenwashing, or there's another term, red washing, if you know what that is. And we need to stay away from that, and we need to get the entire industry into the marketplace as quickly as possible and get to early majority adoption.
So we are a bit over time, but we have a couple of more questions. So Sean Thomas was actually asking, so development of multiple products and that meet high technical specifications demands high capital. Does your model imply go big or go home?
No, not at all. That's why I said that if you're using cook stoves in Africa, and by the way, we're lining up more than 20 joint ventures around the world. We have 5 in the United States, and 1 in Colombia, 1 in Canada, and 1 in Zambia, Africa. But that is for mining processing. That's our Inelastic market. But there's parts of Zambia that they're not going to be using our technology. They're going to be using small technology. There is room for all sizes, everything from the T-luds to the cook stoves to our size processes. Pyreg has a large size that processes biochar, and they are part of the biochar community, and we welcome them, and we want to see them adopted. So there's all different levels and sizes, but in order for it to occur and spread that adoption into early majority, we need to cross that chasm with the proper business model. At least that's our opinion. And we believe that our joint venture, 50-50 joint venture approach spreads the wealth. And one thing else I should say, Christian, that I left out is that we follow the 17 Sustainable Development Goals of the UN. That means in the cultures that we operate in, women are as important as men. And in fact, in Kenya, our joint venture partners are two women that are phenomenal. And in Colombia, our joint venture partner is our phenomenal. Angela has been using biochar for 10 years, and she's one of the most foremost examples of quality coffee and cacao farming using biochar. In her right now in Colombia, there's a drought, and if you look at her farm using biochar, it works great. The farmers next to her look like they're in a drought, and we're trying to create the adoption at a larger scale there in Colombia and other parts of the world. But there's room for everybody. And Sean, I welcome you aboard.
And the last question for today is I will have to modify that a bit. So I think he meant graphene. So the original question was, graphite is a great product. Is it a general product that one can isolate from slow or fast pyrolysis? And how much can you isolate by 1 kilogram of biochar? Or what do you mean by graphene-like material?
Oh, you're asking me the question,
Yes,
not the guy
yes.
that asked the
No, no,
question.
no,
Okay.
I
Okay.
was
All
interested.
right. I just want to make sure I understood correctly.
I
So,
mean, graphene is difficult to produce. So what is a
no, it's
graphene-like
okay.
material?
I got it, Christian. I know we're almost out of time. So I just want to I'll try to get this succinct. Graphene-like char is like everything else. It's prescriptive. And there are different types of graphene molecules. Everybody knows that graphene is a single layer molecule that comes from graphite and is processed through different processes. There's different manufacturing processes of it. And it's mined. The good news is you can use biochar uh, at a certain temperature and residence time, and you can create a graphene-like material. It's typically, just for the people out there that are in the science area, it's run typically at around 900 degrees centigrade, but there's a variation and a wedge and a breadth on that, and it depends on what the use of the graphene is for. Graphene is used in many technologies, from wind turbines to our cell phone technology to solar panels. You can't imagine what it's used in. It's used in a lot of electronic components and EVs. Hopefully that answers the question.
So you're not using it as an input material to this flash graphitization thing,
Yeah,
or
yeah.
okay.
And like as the questioner asked, there's different types of pyrolysis. There's slow pyrolysis, there's fast pyrolysis, and there's flash pyrolysis, and they're all different. So you have. I'm not suggesting that one is better than the other. It depends on what you're using it for. Just think, if you were a surgeon, would you use a GE scope or a another scope brand? It doesn't matter. The question is, or does this scope have other features that the other doesn't when you're doing open heart surgery? You want to use the ones that meet the need of the patient. That's the way we look at it.